Operational cloning simulations have 7 possible steps. You start by downloading an empty DNA template. After populating the DNA template, you will create a project. Projects group together different variations of DNA. Once you have a project, you can upload your DNA. If your project has validation, structural, or logical errors, you can view these errors. If the DNA validates correctly, you can either create a preview or build and run a clone. Once the clone is running, you can start viewing results. The DNA workbook contains all the information OC requires to build and run a clone. We refer to the discrete worksheets in the template as the genes of the DNA. The genes are logical groupings of the concepts that make up the DNA. The DNA concepts are a vocabulary with which you can describe your supply chain. In this session, we will walk through the genes and the concepts of OCDNA and illustrate the concepts by example. The network, companies, facilities, and network node genes describe the internal network of facilities and companies in your enterprise. Network describes the top of the organizational hierarchy. Company function can be used as a composite concept to represent a combination of your business, the legal entity, and the supply chain function being performed in the particular facility, such as finished goods distribution. In this example, we use it to represent the legal entity only. Facilities are the real estate locations where your inventory is stored and handled. A facility has an address, and you can optionally define its latitude, longitude, and rotation to position it in Google Earth. A facility and a company is linked in the network node's gene to represent a node in your network. In this example, we have only one company and 3 facilities. All gene data are entered either in reference to the network, a node, or the facility. All measurements are also summarized either by node or facility and can be selected when analyzing results. The physical infrastructure costs and activity recovery rates genes represent the logistics costs in your network. You maintain the physical infrastructure cost for a node if the logistics activities are insourced, and activity recovery rates if it is outsourced. You can maintain both for the node if you want to compare the 2 options for the node. Populating the physical infrastructure cost gene enable OC to calculate the logistics cost related KPIs that you can use when analyzing results. Cost component groups cost elements, and acquisition type indicates whether the cost component is a capital or a non-capital expense. Amortization years and cost of capital are only maintained for capital items. Cost unit indicates whether the cost component is required in establishing the facility or whether it is a monthly recurring cost. Populating activity recovery rates enable OC to calculate the 3PL fees that will either be paid or received depending on whether you are outsourcing or are the service provider. The 3PL activity concept represents the billable activities that a 3PL performs. The next 6 genes combined represent sea, air, and land-based transport. International sea rates enable OC to calculate inbound transport costs for freight that arrives by sea. The origin and destination port, combined with the carrier, allows OC to determine the sea rate. Sea rates can be maintained for 20-foot, 40-foot, 40-foot high cube, break bulk, and LCL freight. International air rates enable OC to calculate inbound and outbound transport costs that have an international air component. The International Air Rate Matrix gene is used by OC to determine a price category for a shipment using the carrier, country of origin, and country of destination associated with the actual purchase order or sales order. OC then uses the International Air Rates gene to rate the air shipment. To rate the shipment, OC first determines the greater of the actual weight or volumetric weight. This value, combined with the price category, service and carrier, is used to find the base charge and weight charge and then calculate the actual cost. Local distribution rates enable OC to calculate the local distribution fees. OC uses the local distribution zones gene to determine the origin and destination zone based on the origin postcode, that is the postcode of the distributing facility, and the destination postcode, that is in the transfer or sales order. The local distribution rate matrix gene is used by OC to determine a price category for a shipment using the carrier, origin zone and destination zone previously determined. OC then uses the local distribution rates gene to rate the shipment. This process is similar to the rating of an air shipment described earlier. The next gene to discuss is the operational resources gene. OC requires operational resources to be able to perform the tasks it generates during the clone run. The work performed by operational resources are summarized across process, task, and event. The number of operational resources represent the discrete resources in the facility available to do work. The number of operational resources dedicated to a particular process in the facility is spread as a percentage of the total available. Resource carry capacity represents the carry capacity of the material handling equipment used in the facility for the active processes. Capacity dimensions are defined in the facility's location sizes gene. Next, we discuss the SKU family's demand and supply gene. The SKU family's demand and supply gene represent the discrete SKUs that flow through the network, the node stocking relationships, and the points of supply. SKU type represent product portfolio or product line and groups SKU families. SKU family represent a group of products derived from a common product platform. SKU families typically use similar production processes, have similar physical characteristics, and share distribution channels and pricing methods. The number of SKUs in family indicate the number of SKUs in the SKU family. Average weekly demand per SKU indicate the average projected weekly external demand for each SKU in the family for the duration of the clone run. Using our example, the number of SKUs in product family PF1 is 21, and the average weekly demand per SKU is 10,555. Therefore, the projected total weekly demand for the SKU family is 221,655 units. The demand figures entered here should only include true external customer demand and should not include the demand from internal network nodes. OC will roll up internal demand from the consuming nodes. SKU number spread and demand spread indicate how the total demand in the family is to be spread or divided among the SKUs in the family. Each data point groups SKUs into a logical subfamily that attract a portion of the demand. Using product family PF1 as an example, it has 3 data points. The first SKU subfamily has 5 SKUs and attract 33% of the projected demand for the product family. Supplier indicates the entities that have supplying relationships with a network node for an SKU family. Suppliers may be external suppliers, that is, other businesses, or internal network nodes. To set up an internal node as the supplier of another internal node, enter the company and facility number separated by a dash as the supplier. Supplier facility indicates the facility where the supplier ships from. The facility-to-port carrier, service, and carrier price category define the transport from the supplier facility to the export port. The port-to-port carrier, service, and international transport mode define the transport from the supplier export port to the import port. The port-to-facility carrier, service, and carrier price category define the transport from the import port to the facility. The average day supply indicates the planned day supply for the SKUs in the family that will be maintained during the clone run. It also represents the replenishment lead time for the product family. Percentage safety stock indicates the percentage safety stock for the SKUs in the family that OC will maintain during the clone run. Unit load and packing level 2 average quantity is used by OC to interpret the packing levels for the SKUs in the family. A unit load is the top packing level and in most cases will represent pallet loads of product. Packing level 2 is the next packing level and in most cases will represent full cases of product. Average purchase price is the average purchase price across the SKUs in the family, and average sale price is the average sale price across the SKUs in the family. Average packet unit weight and volume indicate the average unit weight and volume in packaged format. The order classes, order distribution, and geographic demand distribution genes describe the order or demand profile of the network nodes and is used by OC to generate the orders to be fulfilled during the clone run. Order class and subclass implicitly represent your distribution channels. Order class is restricted to 3 classes, A, B, and C, and each order class can be divided into a maximum of 10 order subclasses. Order class proportion indicates the projected proportion of the total demand in the network node that a order class will consume. It is also used to indicate the projected proportion of the total demand in the order class that a order subclass will consume. Average number of sales order lines indicate the average number of SKUs ordered for this order subclass. Order country, order state, and average number of orders tell OC how, on average, monthly orders associated with a network node are geographically distributed across country and state. Number of orders class A, B, and C tell OC how many of the monthly orders are in order classes A, B, and C. Demand distribution country, state, postcode, and demand proportion by postcode tell OC how the total demand in the network node is spread across country, state, and postal code.